Good morning, friends. This video will be on application of rational functions. This particular problem says that the population of a species of insect was being tracked in a small section of the rainforest by environmentalists who were trying to revive the species. The environmentalists were able to model the population of the insect T days after the beginning of the study. After the study began, by using the equation or the function pt is equal to 45 plus 28t divided by 5 plus 0.04t, which is a rational function. Then the question says how many insects were in the section of the rainforest when the study began, and if the model holds true, will there be a limit to the number of insects population in the section of the rainforest, and if so, what is the limit? Okay, so a couple of things I want to point out to you first of all is that it defines the variable t as days, so that's the horizontal axis represents days, and we know that also because that's the variable where the x-axis would normally be. So if we think about our axis system, here is the t-axis for time, and then this is going to be the p-axis for population. And because this is an application problem of living things, we really only need the first quadrant information. But anyway, there we have that. Okay, so basically, I also have on the right-hand side over here my notes, just in case we need it. But when it says how many insects were in the section of the rainforest when it began, okay, so they are asking, that is asking for what is the y-intercept. That's what's really being asked. They're asking for the y-intercept. And the reason that is because the y-intercept is 0 whatever. And 0 means no time has elapsed. So in other words, at the beginning. Well, if we take the equation and we put zeros here and here, then basically what we have is the number 45 divided by 9. I'm sorry, 45 divided by 5. And 45 divided by 5 is 9, so we now know this number. This number right here should be the number 9. So there were 9 insects. So when these environmentalists began, there were a total of 9 insects. Then the next question says, if the model holds true, will there be a limit to the number of insect population in the section of the rainforest? And so the limit would be the asymptotes, and not just the asymptotes, it's going to be the horizontal asymptotes. So this right here is asking you for the horizontal asymptote. So if we remember from our notes, horizontal asymptotes are a comparison of powers. So if we go back to our problem and we compare our powers, this is to the first power. This is to the first power, and so is this. So the powers are the same. So if the powers are the same, we are going to take 28 and divide it by 0.04. So we are going to take, and we're going to say y equals 28 divided by 0.04, and that makes y equal to 700. So there is a horizontal asymptote that runs right through here. That is the number 700. So if we're keeping track, this is, whoops, don't know where my pen went. This is y equals 700. This right here is the 0.9, and the asymptote itself, or the function itself, looks like this. And then over here, but this wouldn't matter. And so, let's see. The answer to this, if the model holds true, will there be a limit? Yes, there will be a limit. And what will the limit be? 700 insects. That is it, my friends. That is all there is to it. So basically, they're asking you for the y-intercept, and they're asking you for the horizontal asymptote. All right, have a great day.